Hello AAG students. I'm putting together this video to try to cover our week 6 topic, well one of our week 6 topics, inscribed angles on circles. So I want to start with some familiar things that we should already know from the last couple sections. We can call this circle A, but angle A or angle BAC they're showing us right now is 160 degrees. So that's a central angle because that angle is located obviously at the center, right? Hence the name. So circle A is the name of the circle. Angle BAC has a measure of 160 degrees. So we're asked to find a couple things down below here. So let's start off with something that we should remember. What is the measure of arc BC? Now notice there are two letters, so that's minor arc BC. So we're going to take the shortcut. Later on we're going to find the measure of arc BDC, right? So it starts at B, pass through D, end at C, so that would be a major arc, right? That's the longer way around. Okay, so hopefully we remember that the measure of the central angle is the same as the number of degrees on the circle out here, right? So in other words, the measure of angle BAC is equal to the measure of arc BC. So I'm just going to go grab that central angle here and say the measure of arc BC is also 160 degrees. Now this isn't length, this isn't feet, miles, meters. This is just the number of degrees on the outside. So again, central angle is exactly equal to the arc it forms. So as you can see, I used the highlighter here to highlight the angle and then kind of point outwards towards the arc it forms. But in this new section here, we're going to be talking about inscribed angles. An inscribed angle has a vertex that is located on the circle. Notice that this vertex, this angle here, has the vertex, angle BDC. Okay, the vertex is on the circle. It's not the central angle. But there's a really cool relationship here, as a matter of fact. So what I'm going to do is I'm going to highlight in yellow the fact that if you notice, look, if I extend angle D or angle BDC, if I extend it, look guys, it actually shares the same intercepted arc. All right, or the arc it forms. Now there's a very nice, simple, very easy to calculate relationship here. So if the central angle is 160, then the arc measure is exactly equal to that. But for inscribed angles, it's going to be half of the intercepted arc. So for example, look guys, if angle D opens up here and meets the circle and forms that arc, then this angle is half of the arc measure it forms. So 160 divided by 2 will give me 80 degrees. Alrighty, so now right down here, the measure of angle BDC is half of the arc measure that it forms. So I'm going to put 80 degrees. Conversely, if I knew the angle was 80 degrees, I could follow it out, right? See where it meets the circle, and then the arc measure would be 2 times the inscribed angle, okay? So let's go down the bottom here. They also want us to find the measure of arc BDC. BDC is the long way around. So this should be nice and simple, right? 360 degrees around every circle. So the measure of major arc BDC will be 360 minus 160, okay? So this will give us 200 degrees all the way around, okay? So that's going to be 200 degrees. All right, guys, so real quick, central angle matches the arc measure. They're equal. But an inscribed angle is half of its intercepted arc, or conversely, the intercepted arc is 2 times the inscribed angle. Let's see if we can apply that over here, right? So here we go. We have a central angle. Central angle is 100 degrees. So as you can see, I've used the highlighter to, follow that path and come out here and say that angle FEG has an intercepted arc of FG. So think about it. We said before, the central angle is exactly equal to its intercepted arc. So if this is 100 degrees, guess what? The measure of arc FG is 100 degrees. Since it's the central angle, it matches, it's equal. Okay, so now let's see what else we have here. What are they asking us for? The measure of angle GEH. GEH. H. Oh, good. So these two angles form, oh, and we are going to assume that since this is circle E, that is a diameter, right? Did they ask for it? They did not, but if they did, the measure of arc FH would be what? 180 degrees. All right, you got it. So I'm going to use the fact that these two are a linear pair, right? Together they're supplementary, so 180 minus 100 leaves 80 degrees left over. So guys, let's think about this, right? If the measure of angle GEH is 80 degrees, right, then so is the measure of arc GH. Okay, so is the measure of arc GH. So let's just think about this here. Let me write down all of the arcs. Arc FG is 100 degrees. Arc GH is 80 degrees. I'm going to mark this down even though they didn't ask for it. Arc FH is also 180 degrees, so that 1, 2, 3 together add up to 360. All right, finally, they want the measure of angle GFH. Now, I want to show you something here, right? Sometimes you might need a highlighter or you might need, a colored pencil or something like that, but I want you to notice that GH is here, 80 degrees. Angle F, or angle, they're calling it GFH, is right here. Now, I want you to notice something. If I take my highlighter, and I like to just kind of let it go past the circle, if you notice, not only does angle GEH open up to form that intercepted arc, but so does angle GFH. Look, if I just follow that path, it meets and intercepts the same 80-degree arc. So how do I find the measure of angle F? Let's go back to our previous example. What did we do to the arc measure, 160? To go back to the inscribed angle, divide by 2, right? So what I'm going to do is take 80 degrees, which is the measure of the arc, and follow it back to the inscribed angle, and it's going to be 80 divided by 2, or 40 degrees. So the measure of angle GFH is 40 degrees. Okay, so let's think here. Wait a minute. It's also asking us for the measure of angle FGE. FGE. All right, well, think about this. We already know two angles in triangle FGE. So I know that this angle plus this angle plus this angle should be 180 degrees. Together, these are 140 degrees, leaving 40 degrees left over. So as a matter of fact, this is an obtuse isosceles triangle. We should actually know that, right? Because FE and GE are each a radius. Okay, so ladies and gentlemen, I hope this gets you started with inscribed angles. Let's remember one last thing. Central angles are equal to its intercepted arc. Inscribed angles are half of the intercepted arc, or conversely, the inscribed angle times 2 gives you the intercepted arc. Alrighty, thanks everybody. Let me know if you have any questions.